Let's design and build some op-amp circuits. The first one, I will give the question that says, let's take V out and make it 2 times V in. And V out is going to be a sine wave of some frequency and some amplitude. And that means that we're going to take V in, which will also be a sine wave, and we'll multiply it by 2 so that V out is 2 times as big. Okay, pretty simple. So we see that the gain is positive and bigger than 1. That says we should use a non-inverting amplifier. So I will take V in and go into the non-inverting side of my op-amp. And I will build a voltage divider for my non-inverting amplifier. I have to choose my resistors, so I know they should be equal so that I get a factor of 2. And then I have to choose their actual value. I could choose 1 ohm resistors, I could choose million ohm resistors. Why would I choose one over the other? Well, our op-amp has a certain specification that says it can only have so much current that goes out of it. So in general, we want to stay in the milliamp range, or tenths of milliamp range. A good fit is always a 1K resistor. So 1K resistors mean that when this is its maximum voltage, we'll do plus 5 and minus 5 volts as a supply. When this is 5 volts, 2.5 milliamps has to come out of the op-amp. That's well within the spec for most op-amps that can typically output 10 to 25 milliamps. The op-amp that we're going to use is the TLV272. This is a nice general purpose dual op-amp, so one 8-pin chip has 2 op-amps on it. So when we look at this particular chip, some chips have a little divot at the top. This one doesn't. Instead, it has a dot in the top left. That's how you know where pin 1 is. And it has 8 pins. So this is pin 1 and this is pin 8 that we count our pins going counterclockwise. And the top right pin is VCC+, that's our positive power pin. And the bottom left pin is VCC-, that's our negative power supply pin. And then the remaining 6 pins are 2 different op-amps. So pin 1 is V out, and pin 7 is V out. And then we have V minus and V plus, and V plus and V minus for those 2 different op-amps. So it looks like an op-amp, and that goes back to the output, and then we have another op-amp, minus and plus going there. So if you're going to be using this V out, you should be using this V minus and this V plus. If you're going to use this V out, you should use this V minus and the V plus. There's 2 different op-amps in this chip. Okay, so now we have to actually build this and choose what are we going to use to create the voltage, the sine wave, and what are we going to use to read it with. I'm going to power this with A1 from my end scope, and I will tell it to generate the sine wave. And then I will read it on channel 1 so I can see what's happening. I'll probably also put A1 on channel 2 so that I know what the input looks like. And that way I can compare the input that I'm putting into my circuit to the output and verify that I'm getting my ×2 amplification. Okay, there's lots of ways to do this. So here's my TLV272. And if you look carefully, written on the chip is actually TL272I. I've got a red wire to 5 volts and a green wire to minus 5 volts, so those are my power pins. I've got my 2 1K resistors for a voltage divider that go to ground. Let's see, what am I missing so far? I have my output that goes to channel 1. I have my input that's going to the non-inverting pin from A1. What I'm missing is I don't have a wire that goes from my output to the input of my voltage divider, and I'm not looking at A1 on channel 2. So let's add some more wires. And notice so far I've been able to color code things nicely. I use green wires for negative power, red wires for positive power, black wires for ground. So when I come back to this, I'll be able to quickly pick up on did I mess up my power pins. The other wires are different colors for different voltages, but eventually I run out of different color wires, so I'd have to reevaluate this closely if I'm going to look at it again. Okay, I seem to have like a white wire as an output convention, so I'll quickly make a white wire to go from the output of my op amp to the first resistor. There. And then I'd like to see what A1 is generating on channel 2. Maybe I'll use another blue wire for that. So remember, when you're building these, don't remove too much insulation from your wire, because we don't want it to accidentally touch and short something. But you have to remove enough so that it can plug into the breadboard. I'm not doing a fantastic job of not making these big loopy wires. So let's see what I mean by that. If I look from the side, these wires could easily snag something if I put this in my bag and they fall out. So ideally they'd be flush against the board. But I'm doing some quick prototyping here, so it's okay that everything sticks out. If I wanted this to survive longer, I'd probably go back and trim all of these so that they were shorter. Okay, we don't really know if it's working until we generate some voltage. So let's take a look at what Enscope is doing. Right now, channel 1 is reading 0 volts, and I'll turn on channel 2, reading just above 0. I can turn on A1. So A1 is hooked up to channel 2, so my input voltage is in green, and my output is in red. Red's bigger than green, so it looks like I'm getting the magnification that I want. I can make the input a little bigger, maybe 2.5 volts, so that the output should go to 5. And I can switch to bipolar, so that I have positive and negative voltages, so I can test to make sure my op amp is going positive and negative. I could zoom in and time a little so that we don't see quite so many sine waves per screen. Maybe that's a little too much. And what we're looking for here is at any given point, is the red signal twice as big as the green? And it looks like it is. If I want to have the signal stop moving around the screen, I could hit single, and the Enscope will start collecting a new piece of data. When it gets to the end, it will move to stop, and it will freeze. I could have left it in continuous and just hit stop, and it would have ended wherever it was. So single is nice sometimes because you get a full screen. And we've got channel 1 and channel 2 on the same sensitivity, both 2 volts per div. So green right now is a little more than 1 div, and red is a little more than 2 divs. So green is should be 2.5 volt peak here. Why don't we go down to something that's a little easier? We'll go to a 1 volt input, and we'll change our sensitivities to be 1 volt, so each div is 1 volt. Makes it a little easier to read. And I'll say single to collect one more. Okay, so we see the green. Here's the caret is 0 volts, so it's hitting positive 1 and negative 1 volt. And red is hitting positive 2 and negative 2 volts. So that's our gain of 2. Okay, how about we build another one? Let's do an inverting circuit just to see what that looks like. So now I will have my V in go to a resistor. I'll have my non-inverting be grounded. I'll use my same two 1K resistors. So if I drew that circuit for you and I said, what is V out in terms of V in? Well, this is an inverting op amp, and the gain is RF over R1, so it's negative V in. So let's switch this circuit around and start yanking wires. I'm going to keep A1 and my channels because I know those are right. I need my non-inverting pin to go to ground, so that's pin 3. So the input's no longer coming from A1. Instead, from A1, we're going to the inverting pin through a 1K resistor. And then I want, from the output back to the inverting pin, another 1K resistor. So I'm going to stuff it in there. And I've got my white wire reading the output. So that should be ready. So I'll switch back to InScope. And we can see the red and the green are opposite in phase, so they're the negative voltage of each other, and they have the same magnitude. So this is our circuit schematic. This is our breadboarded circuit. We never want to draw this really. There's an infinite number of ways to build this. What's really important is that you draw your circuit schematic so that anyone can rebuild it. You label the components, the inputs and the outputs. It's also a good idea to label where you've put your oscilloscope probe. So here's channel 1, here's channel 2. I've also attached A1 to that point. That's generating the input. Usually we leave off the +5 and -5 notes for the power supply and the op amp. It's assumed that they're there. If they're not there, it doesn't work.